Your teacher today is Dr. Bosa, Science. Dr. Bosa is a teacher at the Science Foundation College, the best school that teaches sciences. Today we are going to study organic chemistry, lesson 14, alcohols, classification, nomenclature, properties, and preparations. Alcohols are organic compounds that contain at least one hydroxyl group bonded to a saturated carbon atom. Classification: A. According to the number of hydroxyl groups. 1. Monohydric alcohols have one hydroxyl group. For example, ethane, propan, all. 2. Dihydric alcohols or glycols have two hydroxyl groups. For example, ethane 1,2-diol, propan 1,2-diol, propan 1,3-diol. 3. Trihydric alcohols have 3 hydroxyl groups. For example, propane 1,2,3-triol. 4. Polyhydric alcohols or polyols contain more than 3 hydroxyl groups. For example, sugar. B. Classification of monohydric alcohols. They are classified according to the number of alkyl groups bonded to the carbon atom that bear hydroxyl group. 1. Primary alcohols have one alkyl group bonded to the carbon atom that carry hydroxyl group. For example, ethanol. 2. Secondary alcohols have 2 alkyl groups bonded to the carbon atom that bear hydroxyl group. For example, propan-2-ol and butan-2-ol. 3. Tertiary alcohols have 3 alkyl groups bonded to a carbon atom that bear hydroxyl group. For example, 2-methyl propan-2-ol, 2-methyl butan-2-ol. Nomenclature. A. Alcohols are named by replacing the final E in the corresponding alkanes with OL. B. The hydroxyl group is taken as a substituted group and its position is given by numbering the carbon atoms in the chain from the side nearest to the carbon atom that carry OH group. For example, 3-methyl butan-1-ol. Physical properties. 1. Alcohols have high melting and boiling points than the corresponding hydrocarbons of similar molecular masses. This is due to formation of intermolecular hydrogen bonds. Consequently, alcohols are either liquids or solids. For example, propane, molecular mass 44, has boiling point -42 degrees Celsius, while ethanol, molecular mass 46, has a boiling point of 78 degrees Celsius. 2. Lower members are completely soluble in water. due to the formation of hydrogen bonds with water. But the solubility of alcohols decreases as alkyl group length increases due to increase in alkane-like character. Industrial preparation of alcohols. 1. From petroleum products. For example, alkenes. Alkenes are hydrolyzed in the presence of acid to form alcohols. 2. Fermentation of sugars. Ethanol is prepared by fermentation of sugars, usually carried out by adding yeast to the mixture of sugar and water. Sugar plus yeast will give you ethanol and carbon dioxide. Methanol is produced by catalytic reduction of carbon monoxide. Carbon monoxide plus hydrogen in the presence of chromium oxide or zinc oxide at high pressure and temperature will give you methanol. Laboratory preparation of alcohols. 1. By hydration of alkenes in the presence of an acid as a catalyst. For example, but2-ene plus water, presence of an acid, you get butane to ore. 2. By hydrolysis of alkyl halides using aqueous alkalis. For example, 2-chlorobutane reacts with sodium hydroxide to form butane to ore. 3. By reduction of carbonyl compounds using lithium aluminium hydrides in the presence of dry ether. For example, propanol is reduced by lithium aluminium hydride in dry ether to form propan-1 ore. Butanol is reduced by lithium aluminium hydride in presence of dry ether to form butane-2 ore. 4. By reduction of carboxylic acids using lithium aluminium hydride in dry ether. For example, propanoic acid is reduced by lithium aluminium hydride in dry ether to propan-1 ore. Absolute ethanol. All aqueous solutions of ethanol yield on fraction distillation a constant boiling mixture or azeotrope of 96% ethanol and 4% water, known as rectified spirit. Absolute ethanol is prepared from this spirit by 1. By storing rectified spirit over quicklime overnight. Quicklime dehydrates the mixture, then pure ethanol, called absolute ethanol, is distilled. Calcium oxide plus water will give you calcium hydroxide. 2. By adding benzene to rectified spirit and then distillation. At 65 degrees, a constant boiling mixture of ethanol, benzene, and water is formed. At 68 degrees, a constant boiling mixture of ethanol and water is formed. Then pure ethanol distills off at 78 degrees Celsius.